Now.
All right. So hello, everybody. Welcome to the ONOS TST meeting. This one is actually doubling as a review meeting for the Peacock release for Milestone 1 accomplishments. So we put together a brief presentation. It's going to be probably most likely a very short meeting comprising of some demos and just brief updates as to what was accomplished up to this point. So just as a quick reminder, the major themes of the Peacock release are to perform a platform upgrade, to kick off the code-based disaggregation into multiple repositories to eliminate the incubator area, and then there were a few other satellite objectives. So without going into further detail here, as that would overlap with the individual updates, I'm going to move forward onto the core and platform. So here is where I'm going to hand it off to Jordan and to Ray for the respective updates on the efforts. Please go ahead, Ray.
Okay. So as part of this effort, we were very far behind in our Karaf implementation, on the order of three and a half years worth. So we decided to just skip ahead and go right for the 4.2.1, which is what supports Java 10. That's the first Karaf implementation that supports Java 10, with the idea that eventually, once all this is done, we'll be able to bump up our Java versions as well. This has been a very involved, much more work than I thought it would be upgrade. The main source of changes has been that in the 3.0 series of Karaf, the OSGI annotations and OSGI classes that you use to interact with things like components were proprietary Karaf classes. And across time, the OSGI became more of a standard, which is a good thing. But the bad thing for us was that all of those classes were deprecated and now moved off into separate OSGI-provided bundles. And so there's just been a lot of source code changes to find the different places. The annotations are slightly different. The other thing that's been a big source of changes that I've been working on the last few days has been the Karaf CLI is now done completely differently. Again, the way they did it is much cleaner. They're now using annotations for things like completers, whereas before we had that awful blueprint file that at least I would always forget about and not understand why my completers weren't working. Now there's actual source code annotations that say, hey, here, this argument uses this. You don't have to have this business of putting in fake references to the OSGI components so that they'll load for you. It's much cleaner. But we use the CLI in a lot of places, and so that's been a source of a lot of drama, shall we say. So where things stand now is we have a functional CLI. We have a partial ONOS that comes up, runs a lot of things. Thomas has been working on getting the GUI to work. We're still having a few issues with that. We don't exactly know why yet. Something most likely to do with versioning on some of the core libraries. And as for ONOS itself, we can do things like start and stop apps, which I'll show you later what that looks like. We can do OK Clean. We can do STC setup. STC itself doesn't run yet. I think it's because some driver somewhere is not loading. I haven't actually looked into that yet just because I'm still focusing on these source code changes. So I guess we're probably not where I expected to be at this point in the milestone. I really expected to be able to show a GUI today, but it just didn't happen. And I guess that's about it.
All right. Thanks, Ray. Jordan, do you want to provide an update on your bit?
Yeah, so I've been working in this milestone on essentially supporting Kubernetes much better for both ONOS and Atomix. In the last release, we separated Atomix from ONOS, and now we're trying to run them on Kubernetes. So the first big milestone for Kubernetes is changing the way that both the Atomix and ONOS clusters are configured. So Kubernetes really uses DNS for service discovery, and so I modified both Atomix and ONOS to support the same, to be able to use DNS lookups to find both ONOS nodes and Atomix nodes, and then implemented Helm Charts. So Helm is a package manager for Kubernetes that allows like templating Kubernetes manifests, and I'll show them in my demo. But I created Helm charts for both Atomix and ONOS that allow for essentially a one-click deployment of ONOS. And so I'll do a demo of that.
That's awesome. And so a couple of things before we leave this this page here. Given the sort of the severity of the update with respect to Karaf, just a reminder that we've decided this will most likely warrant the major version number upgrade. So we will most likely be titling the ONOS Peacock as a ONOS 2.0. We may actually release 1.5 as a as kind of a partial release, because there's still some valuable work going on a current master, but the 4.2 branch for working on Karaf 4.2 is going to be promoted to master, and that's most likely going to be called ONOS 2.0, because there is, normally we try to guard against non-backwards compatible changes as far as our APIs, but these changes are basically out of the scope of our influence, and so we don't really have any control over them. It cannot be helped, and so the lack of backwards compatibility really warrants upgrading the major version number. So there's just a quick reminder. And again, thanks Ray and Jordan for all your really heroic work here. That's really awesome. Thanks. So let's move to P4 GNMI and GNOI, and I think we have Carmelo or Yi online to represent that. Carmelo, do you want to take?
Yeah, I can take that. So the first milestone for this release was to work on making sure that we can have Stratum switches running P4 working alongside OFDPA switches in Chalice. So for this, first we started by improving the P4 runtime southbound. So the goal was to demonstrate not just the basic Chalice forwarding feature, but also the resiliency one, meaning restarting switches and restarting ONOS instances while traffic is flowing. So we improved the P4 runtime southbound to support reconciliation of action profile groups members, which are equivalent to OpenFlow groups, after which restart or being failure. We also did some improvements on the way pipeconf drivers are managed in order to support restarting ONOS instances. And also we made some minor changes to the implementation of the P4 runtime client to become more compliant with the draft of the version 1.0 of the P4 runtime protocol, and we proved that by testing using with Stratum. We also did minor changes to the implementation of Fabric.P4, and again, this was the implementation of the P4 code, so the pipeline design, and also the pipeliner driver in ONOS. And this was done to guarantee interoperability with OFDPA switches. So we are able to demonstrate interoperability of a Stratum and OFDPA switch in different modes. For example, live spine or a IPv4 unicast multicast routing between two live, one Stratum, one FTPA, and also paired lift for resiliency, where one is an FTPA one and another one is a Stratum. We also work on INT, testing INT support in Fabric.P4 on hardware, at least for the source and transit functionality. And we also refactored the INT service application to work with ONOS on cluster mode. Before it was working only with single ONOS instance. And that's pretty much it.
Oh, this is great. That's awesome. Do you see, just a quick question, do you foresee, yes, for you, do you foresee any issues with, with the upgrade of the platform to, hopefully none of that will delay you, but do you have any concerns about that from a viewpoint?
Not at all. Not at all. I mean, we experience, it's always a bit tricky to handle all the, let's say, runtime dependency requirements when it comes to the protobuf generated classes but I'm not sure that this platform upgrade will. I mean, I'm not sure moving to Karaf will impact that part. But besides that, no, I don't see any issue with that.
Yeah, I guess that's true. Yeah, we've addressed a lot of those collisions in a past release with the bazel upgrade. It's true.
Mm-hmm.
Well, thank you, Carmel. This is great. Okay, next is GUI 2. I don't think we have Sean Condon online, so let me just try to talk through it. This is basically an effort which is a continuation of the effort that was started under the OWL release, and this is to upgrade the UI into using Angular v6, I believe, because we were stuck on Angular older version of Angular. I forget exactly what version we are, the GUI, the original GUI is using. And so Sean, pretty much, I think by himself, maybe a little bit of help from Stephen Burrows, are working on basically upgrading the UI. It's going to be split as its own application, so that it will be loadable completely separately rather than as a built-in. This work right here is basically just a continuation towards the end. It would be good to have Sean online to represent the work. And somebody's joining. I'm not sure whether that is him. But that's kind of all the update that I have, because I've been, for the most part, hands off on this. This is really primarily just his work. So I can't really do it justice. QA, do you want to provide an update?
Yeah, is John online or in Menlo?
He's not in Menlo.
No. Okay, so I can cover this. Well, for me, I have been focusing on Siba, so I haven't really started any new tasks for ONOS GUI, but except for the checking nightly test results, validating patches or releases. But this item here goes to John. I know he's been working on fixes and enhancements to HA tests since we separated Atomic cluster from ONOS cluster. Well, that's the only item we have, but we do have plans for a demo, but unfortunately, maybe not this time. We'll be spending more time in October and November, and I think we will give a demo. We'll target the next review meeting.
All right, thank you.
Sure.
All right, so I think we can, that's all the updates we have for different areas, so we can probably give a couple of the demos. Brian, do you want to pass control over to Ray? Or are you ready, Ray?
Yep.
Understood.
And it's not doing anything. Maybe I'm not sharing. Hold on a sec. Entire screen, share. Boom. There we go.
Yep, I can see it.
All right. So what I'm going to show you a couple of things here. Go away. First thing is going to be I'm going to show you what the current invocation of ONOS looks like, just to give you an idea of what the new CLI looks like. You invoke it the same way as before. You can do OK clean. You can do STC setup. It's really no different that way. We still package and invoke the same way. Why is this not doing anything? There we go. So right now we're operating with the base 4.2.1 package. We haven't done the work yet of making it offline capable. That will come later once we have all the dependencies in place and stuff. There's no real point in doing it now. You can see the log file format and everything looks very similar to what you used to. It's a little more chatty than the old one was. I think I'm going to do some work at some point to turn some of this yammering off. I don't think we need all this stuff. It's nice now, but I think for regular users, regular developers, it's going to be super annoying. One caveat is right now the ONOS client does not work because of an unfortunate bug in the way that Karaf is handling SSH. When you run it, you get no new lines, which, as you can imagine, is really awful when you're viewing formatted output. So we are actually using the Apache Karaf client just so we don't make ourselves crazy with this stuff missing. This part you see looks pretty much the same. What's different is, so let's look, for example, if I do app. Now, did you notice that it's red, meaning I don't know what you're talking about? Now it's blue, meaning cool, I know what you're talking about. Completers work the same. I just did a tab and I got that. But now if I do deactivate and I hit tab again, you see there's this list down at the bottom. When there's a reasonable number of options, it sort of embeds it right in the window there without having to ask you about it. You know, other than that, it works basically the same.
Have they removed that annoying Control D bug?
I don't know.
Where if you
haven't gotten there yet. Like, let's see what happens. If I hit Control D here.
No, Control D there will exit you out, but go back in.
Oh, when you hit the Control D button, when you hit the Control D,
now go back to the beginning of the line and hit Control D.
So
no, before you hit return. Type something.
Like
type something.
And then Control D.
And then then go to the forward. Go to the beginning of the line. Control A.
Okay. Okay.
Don't delete it. Yeah.
Yep.
Now hit Control D to delete forward. Hey, that was worth it. That's the whole thing that's worth it.
Oh, right there. Yeah, absolutely. Oh, yeah.
The whole upgrade is for David's Control D. All right, there we go. All right. So I earned my.
That's a very good point, David, because you wouldn't believe how many times I've fumbled.
Oh, yeah, me too.
The way you used to kill the session when you did that?
Yeah, yeah.
Nice. All right. So the other thing, so that's basically what the CLI looks like. You can see it's similar but improved. Some of our branding is not there yet. It says Karaf at root, doesn't say ONOS. We just haven't figured out how to do that yet in the new stuff. But that's cosmetics. What I want to show you, which is going to be important to anybody who's doing development, is what these changes actually look like. So they fall into two important things that are going to trip up everybody. The first is components are different. We use components for everything. And so anybody who's got third-party code that's got a component in it is going to have to make source code changes. And that's why I made the suggestion of bumping up to 2.0, because there is no backwards compatibility path here. And the reason is, I don't know if you can see the whole, yes, you can. So on the left side, we have what master looks like. And everything comes from this org Apache Felix SCR annotations package. So we used to use the annotations that were actually embedded in something that was provided by Felix and Karaf. Now on the right side, you can see we're using this org OSGI service component. These are released by the OSGI consortium. They have nothing to do with Karaf. Karaf uses them the same way that we do. So again, this is a good change because we're taking something out of Karaf and Felix and promoting it into sort of a public place, but it's a total pain in the neck when you have to port over because you have to just change all these things. The other difference is how you declare a component. So you can see on the left, we have the one in master, and we basically say component immediate is true, which means bring it up when the system boots, and at service. There is no more at service for components. The way that services are done now is you can see on the right here, you give an array of the interfaces that you export. That's the way you do a service. The reason they did that is because in the old way, when you had at service, basically everything you implemented was exposed, whether you wanted it or not. Now you can be specific about what you want. You also don't have this additional at service thing. You now put it in the component. You can see down here, one of the problems we're still battling with is this at property. That's gone completely. This notion of being able to supply properties and override them through the JVM args is not implemented at all in the new OSGI. There are a couple of ways that we think we might be able to do this, but it will require a bunch of sort of changes elsewhere, and that'll be the next thing that I work on is trying to get that working again. So the other big change if I can find the proper window here, is the way that the CLI completers work, and the CLI in general. So we still use this @ command. You can see on the left what we used to basically say is scope is ONOS, that's ONOS : the name of the command and the description. Now what we have to give it is we have to give it this @service tag. Now I just said we don't use @service anymore, yet in the CLI we use @service. This is a different kind of service. This is an internal Karaf thing. The only reason we have to do this is because this is not an OSGI thing, this is a Karaf thing. And it's a little bit annoying because all commands and all completers now have to be services. And the reason is because they're all looked up via the OSGI stuff rather than being looked up through that stupid blueprint file. You can see the arguments are similar, but the big difference here is this @completion. So what that's doing is that's saying this argument at index 0, use this completer, please, when someone hits a tab. This is what makes it such that we don't need the blueprint file anymore, so it makes our lives much easier. But there are a lot of places we use completers, and I have not gotten through all of them yet. So again, anyone who's doing development of something like an app that has its own CLI that's going to want to use completers, they're going to have to follow these new rules. So my feeling is once we're through with this, we'll probably write up some kind of a cookbook that says, here are the things that are going to bite you. David, I know you have some off-world apps. That, I don't remember if you have CLIs in them or not, but this may bite you. I know that Cord, for example, has apps that this stuff might bite them as well. So I think having this cookbook will be a really important thing. The other subtle difference is the execute method is now called do execute. That one's not so bad because if you don't do it right, it just won't compile. That's, again, a change in the way that the Karaf CLI works. So does anyone have any questions about this stuff?
Yeah, so I have a question. So if, for example, like I have a code that uses this component service annotations, and we need to apply the changes that you mentioned, what happens if I don't do that? Will you still be able to build ONOS? I mean, are you required to update all classes inside ONOS to follow the new scheme, or we can do it in a more gradual way where each developer takes care of updating its own code?
You'll have to make source code changes one way or the other. So if the services are missing, obviously your services aren't exported, nobody can find them. In terms of compilation, the annotation @service is now gone. So your code will not compile once you flip over to the new ONOS dependencies.
I see. So at some point you will update the dependency file, and what the build will break until everyone updates its own classes.
Well, I'm fixing the entire build.
Okay.
Once we switch over from this now Dev 4.2.1 branch that basically only Thomas and I are using, once we flip that over to 2.0, everyone's code will build, everyone's CLIs will run. It's two things. Moving forward, people will have to get used to this new scheme.
I see.
And anyone who's got sort of off-world code that I don't have visibility to will obviously not get fixed.
Okay. There's a lot of work. Thank you very much.
This is one of the reasons for doing the work before we disaggregate the repository, because right now we have it all under one umbrella, which makes it much easier to deal with and find all of those things. Once things scatter, that sort of thing will become a little bit more difficult. Not impossible, but it's a little more difficult.
Got it.
This is great, Ray. Is there any other questions for Ray? If not, then you can probably pass the ball to Jordan for his demonstration of running ONOS cluster with Kubernetes. And again, thank you very much, Ray. This is really awesome work. I seem to have lost audio. Can you guys hear me?
Yes.
Okay, good. Things were very, very quiet.
Everyone is contemplating all the work they have to do for this new Karaf upgrade.
You guys see my screen?
Yes.
Excellent. Okay, yeah. So for the work on Kubernetes, essentially, like I said, there are two components. We have to enable Kubernetes deployment for both Atomix and for ONOS. And so there are two new projects on GitHub created for each of these. So under the Open Networking Lab account, we created an ONOS Kubernetes repository. So this is where all the scripts and Helm charts for ONOS are, and I'll go through those. And then in Atomix, as part of the Atomix community, so the Atomix community can maintain it, there's an Atomix Kubernetes project, which is here. So if you're interested, you can go and look through documentation. But I'm just gonna show sort of a little bit about Helm and how it's configured. So
now that you have Helm charts for these two, are you working with Cord, Sibo to ensure that they use these Helm charts as dependencies when they start up their instances of ONOS?
Yeah, so I've been talking to Gopi about this. I think it's actually a lot of these features, a lot of the features that have been added to ONOS are ones that I've heard from the Cord team about them having issues with as far as deploying ONOS on Kubernetes. So I think it'll be a huge improvement. And so yeah, I'm talking to them, and we certainly should converge on a common set of Helm charts. There's no reason that we shouldn't be able to do that.
Okay, thanks.
Yeah, so Helm is a Helm chart is basically just a set of templates that tell Kubernetes how to deploy something. So in the Atomix case, the primary template here is called a stateful set. So a stateful set in Kubernetes is a set of nodes that have persistent identifiers. And so this template essentially tells Kubernetes how to deploy it. So there are, for example, there's an init container here. So this is a container that basically runs before a pod, which is more or less a node or a set of containers that runs as the actual service. So in order to deploy Atomix, we run an init container. So this init container generates an Atomix configuration out of both user-provided arguments and information that it gets from Kubernetes about how the cluster is configured. And then primarily, once that configuration is generated, it's mounted onto the primary container, and Atomix is run. So these are the Atomix arguments saying, pick up the generated configuration files and then run. And there are Kubernetes handles monitoring and stuff. So you set up like a readiness probe so that Kubernetes can decide or determine when the Atomix nodes have started, a liveness probe so it can determine that they're still alive, so it doesn't need to restart them and things like that. And so the cool thing about Helm is that you can override configurations to customize your deployment just through the command line. So when you install a Helm chart or basically deploy a cluster, you can either provide a file with value overrides or just supply them on the command line, and I'll show how that happens. And so, for example, the Atomix Helm chart can be configured with any number of replicas. You can configure logging, provide custom Atomix configuration, tell Kubernetes how the pod should be distributed on physical nodes, set up how data is persisted in Atomix and things like that. So for ONOS, in this ONOS repository, there's this charts folder, and under ONOS is where the ONOS chart is. So it's structured really, really similar. So in the case of ONOS, we structured as a deployment. Well, actually, the cool thing about Helm also is you can add dependencies. So essentially, when you run by adding the Atomix dependency here, when you run the ONOS Helm chart, it will first deploy, it will deploy an Atomix cluster at the same time. And the ONOS Helm chart is designed to configure ONOS to connect to the Atomix cluster that's being deployed with it, which is kind of cool. So that's what makes it a one-click deployment of both Atomix and ONOS. So in the ONOS case, we have a similar init script that handles the configuration. And so the way this works is basically it waits for the Atomix pods to come up, and then configures ONOS with the new configuration format, which uses DNS. And so this generates this portion right here is basically generating a cluster.json file, which I'll show you. That tells ONOS
How does ONOS react if the Atomix cluster goes down and then comes back up? Won't it reconnect?
Yes. Yeah, it will.
So this wait is not really needed. You should be able to start them in any order, yeah?
So the reason that this is here now is because so far the charts are pretty unstable still, and it's not even reliably starting the ONOS cluster with this wait in here. So I may consider removing it and trying it at a later time. Well, so I think the problem is that when ONOS is coming up, one of the problems that we've run into in the past is that Karaf has timers for component activators. And so if a component, especially the storage service specifically, takes longer than, say, 10 seconds to connect to the Atomix cluster, Karaf will, you'll see a lock timeout in Karaf and it'll start retrying. And so it'll keep retrying activating the storage component. And
Okay.
Currently the storage component isn't cleaned up well enough for it to be retried like that. And so a lot of times when we see that, we see sort of just cascading retries, and ultimately Kubernetes will have to restart the ONOS pod anyways. So yeah, I mean, it's a work in progress. We'll have to work on it. You'll probably see when I do a demo of actually deploying the Helm chart that it has some weird issues. Yeah, so actually let me do that. So this is sort of what command actually. Yeah, so this is what a sort of command looks like deploying the ONOS chart. So these set options are overriding values in the charts. So this is saying use the latest ONOS image, deploy 2 ONOS nodes. This overrides the Atomix image that's being deployed with it, deploy 3 Atomix nodes, and then this is telling Kubernetes to ignore the distribution of pods on nodes, which is just a default needed for.
Is anyone having trouble seeing the command?
Pardon?
I
can see it.
I'm seeing it.
Okay, because I'm frozen on a screen that says clear. But all right, well, carry on.
I'm seeing it. So
Okay.
so now with the Atomix separate containers, you can have one replica of ONOS, 2, it doesn't matter. The ONOS, the processing is now not part of the raft algorithm.
Yeah, exactly. Yeah, so having two ONOS replicas is perfectly fine, and you'll get. We actually, last time I was up in Menlo, John and I did a test of killing all but one ONOS node, and it worked pretty well. So there are no longer the quorum requirements on the ONOS nodes themselves that used to exist in 1.13. So you can have, in this case, two ONOS nodes and 3 Atomix nodes. Yeah, so when you run Helm install, so you can see actually what Kubernetes is doing, or what Helm is doing actually. So it's creating a bunch of Kubernetes services, which essentially define how pods are reached through the network. Creates an ONOS stateful set, creates an Atomix stateful set, ONOS deployment, and then a bunch of pods. And we can see, yeah, so the ONOS pods, or the Atomix pods have already started, and then ONOS pods, their configuration finished, and then they were started. So if I log into an ONOS pod, I don't know why it's hanging. So this is the new ONOS cluster.json format. So I mean, it's the same format, it's backwards compatible, but previously ONOS only accepted an IP. And so what I added for Kubernetes is the addition of a host field. So the host field is optional. You can provide either a host or an IP. And essentially each time ONOS or Atomix connects to a peer, it'll do a DNS lookup so that Kubernetes can move pods onto different IPs. Yeah, so the ONOS nodes are up.
Is ONOS contacting the Atomix cluster
Yeah.
through a virtual IP?
Yes. Yeah. So, well, so let me see if I can.
If Atomix is essentially a Kubernetes service, right? Is it fronted by a virtual IP or what?
So this is so these in the storage configuration, these are essentially the Atomix nodes. So we're providing ONOS with the.
You're not using Kubernetes load balancing to contact Atomix ONOS.
No, because no, we're not using load balancing because they're still RAF clients, and so RAF clients need to be able to connect. I mean, inside of ONOS are still RAF clients, so RAF clients need to be able to connect to specific nodes. For example, they'll connect to some node in the Atomix cluster, and Atomix will respond to them with the RAF leader for that partition, and they still connect directly to that leader. So we have separate persistent IPs for different Atomix nodes. If that makes sense. And then the other component is, yeah, one of the big differences between 114 and 115 is that in cluster.json previously, essentially in the storage configuration, you were listing all the ONOS nodes. But you notice in this case, the only ONOS node that is listed is the local node. So this is essentially the configuration, the host and port to which this ONOS node binds, and then a list of Atomix nodes. And so ONOS will connect to Atomix, and Atomix is essentially providing service discovery for the ONOS nodes. And so ONOS nodes will connect to Atomix, and then Atomix will notify them of the other ONOS nodes, and then they'll connect to each other.
Is there a reason why you index the ID numbers at 1 and index the host names at 0?
So that's just for readability. I don't know. Just so the 0 indexing is provided by Kubernetes. So this is a component of stateful set. Basically, a stateful set will create a set of DNS entries that start at 0 and increment up to the number of pods in the stateful set. And so I just convert them to 1 for the IDs, which are basically strings that you can use to identify, for example, nodes when you run the nodes command inside of ONOS.
So I'm still working through some of this. Why does the ONOS nodes have to know about each other if data storage is going through Atomix? What are they doing? What peer ONOS peer communication is there?
So this is for example, there are still a lot of protocols that run on the ONOS nodes only themselves. For example, the flow rule store. Let's say, yeah. So the flow rule store is essentially just a primary backup protocol that runs only on the ONOS controller nodes, and it's optimized in that way for faster I/O. So when a flow is looked up in the flow rule store, it's always a local read. And so, and for all the east-west communication in ONOS, that's the reason that ONOS nodes eventually learn about each other. They don't have to.
I'm just wondering what is happening east-west as opposed to just always using the store service, Atomix, for using the flow store.
Yep.
And you can always cache things locally if you need with TTLs to time out. Why not have one storage mechanism?
Yeah, so I think there's an argument to be made for that. It's a massive refactoring effort. That's a more long-term thing than could be done currently. Like for example, the device store The device store is another example of a DOS protocol, and the device store is there we go.
So,
Yeah, I mean, the device store is one store that's shown to be pretty fragile, and so for the time being, keeping that replication there is sort of favorable. I think there's an argument to be made, like I said, for pushing more replication off the nodes, but we have to do so carefully to not affect performance, because a lot of the reason that the eventually consistent protocols are used on the controller nodes is because, like I said, we get local reads, but yeah, you can do caching and things to overcome that. But yeah, I think that's a more that has to be a more long-term refactoring effort than can be done in one release cycle, which is how long it took to move the Atomix nodes out of ONOS in the first place.
Yep. All right. Thanks.
Anything else?
I'm sure I'll come up with something.
I mean, you can email me and we can talk about it.
Yeah. Thanks.
That'd be fine. Great.
right, I think next on our agenda is Carmelo, right? Brian, would you mind passing control to Carmelo? Perfect.
Yes. What happens if I deny control to go to meeting? Can you see my screen?
Yes.
Okay, so I don't know why GoToMeeting wants all those permissions. So yeah, this demo is basically a short version of what we presented at ONS in Amsterdam. Well, you can see the ONOS UI right now. I'm running ONOS 1.14, but all the changes that I'm going to demonstrate today are being cherry-picked to 1.15. Clearly, for demo stability reason, we prefer to work on 1.14 instead of working on master. So here I have a two-stage leaf spine topology. This is the first stage, and this one on top is the second stage. It's a mix of stratum and OFDPA switches. It's 5 stratum switches and 5 OFDPA. The stratum switches are from different vendors, like CatchCore, Inventec, Delta. They all used Reflectofino as the switching silicon. And they run Stratum as the switch agent, and we use P4 and time to control them, while the OFDPA ones are controlled using OpenFlow and they're all from Acton EdgeCore, and they run different flavors of Broadcom chips like Tomahawk and Trident 2. So I already have some traffic running in my network. In this case, I have a number of hosts, virtual hosts connected to it. We also have connection to 2 upstream routers to which we are peering using 2 internal Quagga instances, acting as BGP speakers. So in this case, I already have some traffic running from this multicast video source. We are replicating this multicast video traffic to a different host in the network, like host 1, host 3, host 2, and this dual home host. What I'm going to demonstrate are the first some resiliency features of Trellis. I mean, these were well-known features of Trellis working with OFDPA. Now we're going to show that the same resiliency guarantees are supported using Stratum. Before doing that, I want to note that we are showing the interoperability between Stratum and OFDPA on different levels. So, for example, we have in this case paired leaf. Where one leaf is an FDPA switch and the other one is a Stratum switch. As you can see, we have this intermediate link between the 2. We have Stratum switches working as a spine, as well as OFDPA switches. And we have cases where an OFDPA leaf is connected to a Stratum spine. So what I'm going to do now, I'm going to restart one of the switches. Actually, first I'm going to start some more traffic. So in this case, I'm going to start a ping to the internet to 888 from this dual ohm host 1. As we can see, the ping is working. We should see the traffic on the UI soon. Going to the upstream router, yes. And also, I'm going to start another ping from host 2, which is right here, to the multicast video source. This is actually to show that there's not much traffic disruption when we restart the switches. So what I'm going to do now, I'm going to restart, for example, one of the spine. We can restart this stratum spine 246, and we should see that the disruption of the traffic flow should be minimum, and we should see both the UI updating to the new path and the ping not disrupted. So switch 246. What I'm going to do now, I'm just going to restart the switch agent on the stratum switch. So we can see the ping is still running both to the internet and between host 2 and the dual home host 1. And we can see that Trellis reconfigured the network to forward the traffic on the right-hand side of the topology. We can show also different kind of resiliency features, for example, restarting ONOS instances. So for example, I can bring down ONOS instance number 3. Okay, we stop the servers. We see it now has 0 devices connected to it, and we should see the UI updating soon. At some point, switch 246 should come up. Might take some time. In the meantime, we can show, for example, bringing down switch 204 and see that the ping to the internet is not disrupted. In this case, this dual owned host is using both links, one probably for the request packets and one for the reply. So I can do demo PI, switch 204, restart. Yeah, and ping is still running. This is mostly I think it's a UI glitch, the reason why it's not showing here. So probably can, yeah. It takes some time for the stratum switches to come up. So they will come up again eventually. What I can do now, I can, oh yes, 204 is coming up. What I can do is to bring up again the ONOS instance number 3. And we can see this is working nicely. So at the same time, we have controller instances failures, switch failures, and still the cluster is able to reach consensus. I guess that's because we're not killing the Atomix instances, yeah. So the cluster is able to reach consensus on new forwarding to apply to our network after failure. So the same way this was working for FPPA is now working for stratum switches. Okay, I don't know if there's any question at this point. So if not,
this is version which of ONOS?
This is 114, but all the changes have
114. Okay.
Yeah, I've been cherry picked to master. The reason I'm not showing master is that because we've been using this for demo development, and I need to do a little more testing on master. Yes.
Very cool.
Yeah. We also demonstrated 2 other things at ONS. The first one was support for Fabric.P4 and INT. Unfortunately, I don't have the INT collector running because I'm waiting for Barefoot to provide it to me. So what I can show right now is basically the ability of first of all the support of Fabric.P4 for INT source and transit capability, and this new INT service application in ONOS was demonstrated also at the All release meeting, but now it's also working with Fabric.P4. So what I'm going to do, I'm going to start traffic flow from this P4 programmable NIC to this other P4 programmable NIC. So this one would be our traffic generator. The first switch will perform the INT source functionality. All the other switch, the stratum switch in the middle, will perform the transit functionality, while this P4 NIC will be our sync device. Let me check something. I think something's missing. Just a second. Okay, there we go. I was missing one host in the network. So I'm going to start a traffic flow between the two. Next, we should see that in the topology, the UI soon. Okay, I'm going to start the sync process on the NIC. Yes, and as we can see now, we have a new traffic flow going from this INT exporter to our INT collector. And the reason why we have a separate host that is sending the INT reports is because this is basically a different interface on the same NIC card that we use to send the INT reports, and is seen by ONOS as a different host. In this case, what's happening under the hood is we have this INT control application in ONOS where we already configured the IP address of the collector and the traffic flows we want to monitor using INT, and the metadata we want to export. So in this case, we are monitoring all the traffic going to this IP address, which is the IP address of this guy here. Yes. And we are exporting the queue occupancy, the port IDs, the egress timestamp, and egress timestamp for each switch. And indeed, if we look at the flow rules of this guy here, which is the source device, we can see that we have flow rules for the INT process. Yes, in this case, this is the rule that is filtering traffic to the IP destination address and is applying the INT instruction. Indeed, if I remove the configuration from the INT control app, which you see the traffic from the INT exporter to the collector to stop. Yes, as in this case. Unfortunately, I don't have the INT collector UI to show that. That's pretty cool, because there where we can see the the actual metrics, the INT metrics being consumed, but that's not available today. That's pretty much it for the INT part. There's another features we demonstrated at ONS Europe. This is a whole feature we demonstrated different demos, but still we show support for Fabric.p4 today. And it is related to the ability of the Fabric.p4 and Stratum switches to perform VNF offloading. In this case, GTP encapsulation. So what I'm doing now, I'm generating a different traffic flow, still from these two network interface cards. This is emulating basically a downlink traffic flow where this is the internet and this is the base station, the eNode B. So in this case, we are generating 56 gigabits per second of traffic of 166 bytes sites packets, and we're receiving the same sites packets. So what I'm going to do now is I'm going to program one of the switches, in this case, switch 208, to perform the GTP encapsulation. And to do that, I'm simply going to install a flow rule to that switch. So the flow rule has been installed to switch 208, and we can see now we're receiving larger packets, size 602 bytes, and that's because of the added GTP header. That's an additional IP header, UDP header, and GTP header. If I'm still good at math, it should be 36 bytes more. Yes. Okay, and that's this concludes the demo. I don't know if there are any questions.
Oh, this is phenomenal. This is awesome. I bet this did really well at ONS demo, right?
Yep.
So any questions for Carmel? All right, well, if not, then I want to thank everybody for putting together the presentation and pretty, excuse me, pretty awesome demos. So we will have another milestone, I think, in end of November. So I'm going to send out a message when that's coming near. So hopefully we can get similar style demonstrations. And in the meantime, everybody keep up the great work, and we'll talk to you later. Thank you.
Thank you. Bye-bye.
Bye-bye. Hey, Ray, can you stop the recording and then maybe either send me the video file or upload it to the YouTube?
Sure.
Thank you very much. Bye-bye, guys.